minutes left, and I was quite curious to together take stock of where acoustic monitoring is at and where you think it's going in the next 5-10 years. I'd be interested to hear, and then touch on, there are a lot of questions around collaboration and what we need to do, and it'd be interesting to hear how we can delve into it together. So my first question is yeah, where do you see, I mean, Dimitri, we've got we did have your question, your challenges put up there, but everyone else, where do you think the immediate challenges and the big moonshots are going to be in the next 5-10 years for really transforming acoustic monitoring? Andy and Ruby, do you want to go first?
Yeah, sure. Yeah, I can start. So for hardware, the challenge really is how to compress data and make it small for others to use, like, so you can get as much on an actual bit of hardware. So compression on the device, filtering on the device, so filtering species that you're interested in, or even just simple like frequency filters.
Are we able to do, sorry, forgive my ignorance, but this was a question that came up a few times. Are we able to do real-time monitoring of species, or is that not in the acoustic? It is. I see David nodding. So yes, it is, and we have devices, because Audiomoth is just, most of the ones I know of, they're just recording to the device and you go have to.
Yeah, it's just, so yeah, Audiomoth doesn't have any way of sending anything in real time. So it's recorded just to the SD card. So as Audiomoth is concerned, it's not possible unless you add an external module to it.
Right, but David, yours are?
No, so same as Andrew's smaller units there. Dimitri's work with cabled mics, a great example of real-time monitoring, and in the case he used with the BirdNet, real-time species IDs with confidence around that. And I think the more, a bit like with facial recognition software, the more people do it, the better it gets. So I think we're at that real inflection point now where more people are doing it, more data becomes available, therefore more annotated data sets become available, therefore the next generation of algorithms builds on that. I guess my perspective on where we are more broadly from an ecology point of view, I think the way ecologists are dealing with acoustic data now is the way ecologists were dealing with spatial data in the 90s when GIS just became a thing. There was this amazing set of tools we could use to ask spatially explicit questions. And for a good decade, we used it to make fancy maps and nothing else. It's like, really? And that's because we'd never been trained in this sort of stuff. We hadn't thought about things in this way. We had to unlearn a lot of stuff before we could really embrace this kind of, and then spatial ecology became a thing. People got trained in it. And we're now in a place where we're doing amazing things. So I think it's going to take a little while for ecologists to unlearn some of the things that they've taken as gospel, and think of ways of using acoustic data in ways that acoustic data is best suited to addressing questions. Now, most of the work I see is early steps, and I think that's I'm not being nasty. It's just it's going to take a while. It's going to take a while for people's headspace to really embrace this. So I guess the example I use with my students is using large scale acoustic data to identify things to species is like using Google Earth to identify trees to species. I mean, you can do it. It's a really good tool to do it at scale, but for now, for many different taxa, if you want to do it, it's actually easier just to go out there and actually do it, to hold a leaf and say, oh, okay, it's this species, or listen with your own ears and go, oh, okay, it's that frog. But we're on the cusp. We're on the cusp, and I think that there's some really, really fun collaborations going on, and there's people now inhabiting that translation sort of space that speak, ecology and models, that speak computer science and acoustic ecology. So I think the next 5-10 years is going to be huge.
Yeah, and I think as a technologist, I mean, I'm coming at this, with an electronic engineering degree. My only sort of ecology experience has actually been on expeditions with the Audiomoth team. And for me, as a technological kind of person who's not familiar with research methods in that way, like I think technologists need to listen and understand, what you guys actually need to best get that data, and actually making a device. The Raspberry Pi is fantastic. That's sort of the inspiration behind Audiomoth, but it's developed for an education tool, not a conservation tool. And it's understanding your use cases and how, if you put an electronic engineer in the rainforest and make them trek for days, they're going to understand a little bit more about battery weight and things like that. And it's completely different. So from that perspective, I think that's where we need to start working together and listening more.
Yeah,
right.
Dimitri, did you want to jump in? Oh, I think you're on mute. There you
Okay. I'm pretty optimistic. I've been doing bioacoustics for nearly 2 decades now, and it's already moved such a long way from where I started. Especially the rise of artificial intelligence. That's a huge game changer, because, like we're saying, you have years of data. I mean, in the beginning when we started, it was basically somebody browsing a day at a time, looking for signals, and you had like an army of people, well, not an army, but like, a handful of people they'd browse through, and they'd spend days and days, weeks, trying to find the signals of interest. Now you have AI and deep learning. You can write algorithms, you can use high-performance computing, and you can do the same thing in literally hours or minutes. For years.
How accessible is that for the ordinary user? I mean,
what we have is accessible. I mean, we want to share our data. That's what we want to. That's the whole point of what we're doing. Is we're trying to develop the tools, and then we want to share it, because that's how you. Because you're not doing conservation, you're not sharing it with everybody. So it's available. If you go to our website or you contact us, we will have to share what we've got and explain in a lot more detail. It's pretty hard to explain everything that we do in 10 minutes. It's just the tip of the iceberg. And so, yeah. I mean, a real-time monitoring, I think, likewise, the example I gave about the right whale, I think on a much larger scale, that expand out for stuff like wildlife. I mean, the other things we're doing is like in the Central African Republic, in Central Africa, you have the rainforest elephant, and we have some organization called the Elephant Listening Project, and they use acoustic monitoring to locate those elephants, because unlike savanna elephants, they're in the forest and you can't see them. So how do you know where they are? You basically listen for them with acoustics. And the other thing you can do in listening in acoustics in a place like that is listen for gunshots. And so if there's poaching, you can develop real-time systems for monitoring something like a gunshot. And you can develop a system where you have anti-poaching groups that go out and deal with that situation. But again, there's challenges, because we've tried to develop gunshots detectors, and there's a lot of other things that you have thousands of hours of data, breaking branches. I mean, there's things, false positives as they're called, that you have to deal with something called a sort of false positive rate, and that's important. If you have a massive response to something like you're going to send out a unit to go against a false positive, you just wasted your resources. So it's important to get those algorithms right, so that you're reducing your false positive rate to make that real-time monitoring tool more effective. So that's another challenge, basically.
Can I just jump in and ask a question? David, do you have a microphone?
Yes.
Sorry, David Brown, not...
Yes, I do.
Do you want to jump in?
Yeah, one of the things is that I use Audiomoth, and it generates a large amount of data, but my poor old humble desktop takes some time to chew through it. And I was wondering whether, do we need some form of AI deep learning that runs on much humbler resources, or do we need some form of cloud-based high-spec computing that can be accessed by everybody?
I think you need both, basically. I mean, they're not mutually exclusive. You can, and we have tools. I mean, they work. It works on a laptop, but it also works on Amazon Web Services. Or if you have a high-performance computing sort of rack of servers, you can do distributed processing on tens of hundreds of CPUs, or you can push it up to the cloud and leverage Amazon Web Services toolset, or you can just do it on a laptop. I mean, it's scalable, so.
Okay, thank you.
Can I pick up on the collaboration piece? I know, Juliana, you've got a question about Audiomoth. I think that's, if someone in the chat has an answer, please do jump in. But with the speakers, I was wondering the theme about moving towards machine learning and automatic ID of species and building algorithms is fundamentally dependent on being able to share data and share information. Where are we, Dave, you mentioned that yours is completely open source, but and open access. Where are we at with sharing acoustic data, and what needs to change, and is there a community of practice? I mean, Dimitri, you've been in this for 2 decades. It feels like, just from an outsider's perspective, things are really rapidly changing just in the last 2, 3, 4 years. What's needed for collaboration in terms of data and information, and there's so much interest from conservationists in using this as a tool. Like, how do we bring people into the community and train them up? That's a very, very broad question. David, do you want to go first?
Sure. So in terms of open access type stuff, I think that's part of a wider movement in science. And I think there's now a growing understanding that, look, share it, get it out there, get it out from behind a paywall. And I think publishers are madly scrabbling to try and re-engineer their whole business case. From a data point of view, again, I think researchers, we don't do this for personal gain. We don't do this to get rich and famous. We do this because we care, and we want to help. And so, with setting up the observatory, there were a few sensitivities with some stakeholders in some particular places where there are rare things, and all we've done there is just blur the spatial location of some sensors, like a handful of sensors. So the data's there, but if you want to know exactly where it is, then there's a vetting process, and you're going to need to talk to the people who own that land or who own that particular reserve. But we've had no real barriers to that at all, and quite the opposite. Some partners were a bit touchy about coming on board, but when we indicated that it was all open access, they're like, "Oh, fine, done, yep." So yeah, the sharing, the collaboration is very strong in this field, I think, and that's reflecting a much wider movement within science generally.
Is there a vision to link up? So that's an Australian observatory. Are you talking to other collaborators overseas to have a global observatory? I mean, then we start touching on some ethical issues about what data's been recorded and all of that. But is there a vision to have it global?
There's rumblings, but pretty rapidly you get to some issues around funding and around storage. I think they're achievable, and storage of digital data is increasingly doable at scale, and archiving it as well. But transferring large files is surprisingly hard. When you're talking terabytes of data, most people do this by sending a hard drive in the mail. It actually is the simplest way to do it. So we need to come up with better ways of doing this. We are tiny players in this space globally, and so I think a few names have been mentioned, a few organisations have been mentioned that are much further along in this. So I think we're going to be riding on their coattails a little. And I think the big bad coronavirus is going to be helping us out no end, because right now genetic researchers are sending whole genomes almost in real time as they're analysing them. So I think a few good crises and we'll be in a much better place.
Dimitri, do you want to jump in and pick up like the collaboration community and data sharing questions?
Yeah, like I said, I mean, my last slide. If we're going to share data, yeah, we need standardization, which is another thing. I mean, one of the things we're working out on at the lab at the moment is for standardization of noise level measurements in the ocean. It's a project called Mentor. And so we're agreeing common units of measurement and coming up with something, part of the issue when you're creating the noise level measurements, you're creating a spectrogram. If you have it at high resolution, you might have something at 1 second resolution and you have a very high sample rate, say 100 kilohertz, that's 100,000. You have a 1 hertz resolution. Suddenly you have an array that's 100,000 by 3,600 just for an hour of data. And if that's at, to use computing like that, it's a single precision resolution, you're generating not just the sound data, but then the products from the sound data, sort of sound level measurements, is another level of abstraction, and you're creating another sort of massive storage issue when you want to, because you need to do that to sort of do the analysis, generate the spectrograms, unless you generate the spectrograms on the fly and then you throw them away, which is another method. So you can do things like that. You can, but you can also, you can use like logarithmic scaling. So we're coming up with this thing called millisecond, which again, it's a logarithmic scale, but it massively reduces the amount of data that you need. So there's sort of methods, there's tools that you can use, but they have to, as a group, as a community, we have to agree on what those standards are, and then we can all share our data, because we have different standards or different formats. If we name our files differently and people don't understand what they mean, then it makes life a lot more difficult. So we have to find a way. So I don't know what the platform is, but some way that we can all sort of share these things.
Yeah, it's a question that's come up in our biologging meetup, in our camera trapping meetup, in our big data meetup. Is standards are at the heart of everything, and we're not there yet on a huge range of tools. So if you come up with
there's other people have thought about this a lot, and I think one of the weird applications that might not be that intuitive is with sport broadcasters. Anytime you're watching any elite sport, there's a team of people behind there that are tagging data. So there's a sequence like cricket, obviously the best sport. There's a sequence of cricket, and there'll be okay, that's this bowler bowling, that's that particular kind of catch, that's that particular batsman doing that particular thing. It's all tagged. And so then when a commentator wants to make a comparison, say, oh yes, that's just like this thing happened before, they've got this almost real-time available library of, okay, this is this sort of, this player, this context, this ball, this whatever. So sports broadcasters obviously have oodles of funding. They do this. They do this in almost real time with video feeds. We could borrow a lot of those workflows.
Andy and Ruby, did you want to pick up and jump into this discussion?
Yeah. So what I think is important is like you say, labeling and tagging data. If you're going to share it to everyone, you need to label what it actually is. Otherwise, it becomes a bit useless. Someone has to listen through it, and you don't want to listen through 24 hours just to get one species. So I think getting a good standardization on labeling audio would be a good first step.
Also the location where it's actually recorded, date, time, all of those things are really impactful in the first studies that we did. Like in the rainforest, we didn't anticipate with the gunshot algorithm so much, the sound of the insects in the evenings and how that would interact with the filters. It is interesting to have that data tagged and logged and understand the time and date and place, as well as what species are already identified. So that will then feed into those machine learning algorithms. It makes it easy to start getting the right models out. Okay,
I'm aware we're hitting the half hour, so I'm just going to give everyone an opportunity to share final thoughts. David, do you want to go first? Final takeaways.
Oh, look, I've spoken enough. Thank you all for your interest. And I guess it's a watch this space thing. Yeah, don't be shy. Don't be shy to reach out. There's plenty of us working in this space. And many of us have come to this space from different discipline areas. There's computer scientists. There's ecologists. There's engineers. There's many different hats in the room. And I think don't be afraid to reach out and use small words to begin with, understanding that across disciplines, some language can be a little tricky, but yeah, the goodwill I think in this space is tremendous. So it's exciting.
Agreed. Dimitri.
Yeah, I was just thinking. I wrote a blog earlier on, and the end of the blog was like we're in an arms race, basically. The conservation challenges that we're meeting right now with global warming and habitat destruction, what we're doing is needed more than ever. And so the need is growing, and so our ability to develop the technology is growing, and it's almost a challenge that we need to do this. And we need to get together as a community to optimize the technology so that we can meet this challenge head on, basically. But I'm optimistic if we get together.
And Andy, and then Ruby.
Yeah, I share both of your opinions. We need to work together and share, and come up all together with a good solution to labeling data, creating algorithms as well. Yeah, it's all about sharing, I think.
Yeah, I'd go with the same. It's all about your feedback. When I'm working with researchers to develop hardware, it's getting that feedback and actually seeing how people use it. And I think that's the thing that's going to take this forward faster, rather than guessing what we think, what technologists think that people need. Like understanding exactly what you guys actually need and creating it for that purpose is, I'm really excited. I've been sort of hanging out with the Open Acoustic team for 3 years, and just seeing that kind of growing it into this world, it makes me feel a little bit better about what's happening in the world and like the environment. And yeah, I'm in the arms race. I'm with you.
What a wonderful way to end. So I'd just like to say thank you to all our speakers, and for everyone who's joined us. It was we had a heap of interest in this topic, and I think it's indicative of just how much acoustic monitoring is growing as a possible tool for conservation, not just ecology. So I will say an hour and a half feels like a long time, but it's also a really short time. So there are a lot of detailed questions that people had about acoustic monitoring that we haven't been able to touch off here. So Talia's dropped a link to both the acoustic monitoring group on Wild Labs and the specific thread we've started to host a discussion about this meetup and the points that have been raised, both in people coming to it and during this discussion. So please do continue the conversation there, and let's pick up some of these discussions and move them forward, and connect people, not just both on the hardware side of things and best practice and comparing different tools, but also on the machine learning and analysis side of things. And yeah, it's a really exciting space. So thank you to all our speakers, and thank you to Talia Speaker, who's on the Wild Labs team, who runs everything behind the scenes. And thank you for all of your enthusiasm and participation. We'll see you next time.